That's unfortunate. All right, what's going on, everybody? I am doing a quick tool talk that Enzo asked me to do yesterday, and 2 days ago, and I didn't have a topic, and I was hoping he would find someone else. But no, apparently nobody else uses any kinds of tools at all. So I wrote one, and we're going to teach a little bit of Golang, and then we're going to write a little bit of simple port scanner, and it works. And then we're going to try a little concurrency, and I'll probably fall back to my cheat sheet, but it could be spicy. So I just set up a simple. Now let me enhance a bit here. So I just set up a simple Go directory here. So you're going to want to bin, and that's normally when you set your Go pass. I'm not going to get into that because I don't need that. That ain't me right now. That ain't it. But normally when you do Go build, it'll build the binary and put it in there if you have your Go pass set up properly. Then there's CMD, which is like where you put your app. And then there's docs, which is where you put all the documentation or all your generated documentation. That all goes in there. And then packages is anything that is like a library or like a header in C with all the code. That all goes in there. And you really want the minimal amount in your like CMD, and that's where the main is. You want as little as possible in there. So to start the Go project, do some live coding. It's gonna be great. You do go mod, and then it's go mod init, and it initializes your go.mod folder, and that just tells the project all the packages you have installed and all the other lovely stuff like the version number of Golang. And then you want to tell what the project is, so you can just put whatever you want really, but it's got to be structured in this lovely Golang format. So I'm going to put my GitHub, which is like common theming. You don't actually have to put, it doesn't have to be a repo if you don't want it to be. So I'm going to call it Real Port Scanner. There we go, Real Scanner. There it goes. Boom. So now there's my Go mod, and there's what? It generates the go.mod folder or the go.mod file. Which he trolling me in Twitch chat? Is that what's going on here? Oh, did you actually ask a serious question?
Let's go, bro.
Is that a serious question or Okay. Golang is a coding language, I believe, made by Google, and it has some of the points are it's kind of like Python and C++ kind of deal. It's got pointers, but it also has it's very easy to write, and the concurrency and assign variables, and you'll see that soon. On top of that, it's really good for microservices because the concurrency, like the threading and stuff, is so good. And there's some other use cases. It's good for web. Oh yes, it's also really good for cross-platform because you can build it for Windows, Linux, etc. So that's why I use it. I use it for servers a lot of the time, and I think it's fun to write. I don't normally cross-compile it much, but you can, and it works just fine usually. Okay, cool. So let's set up our new file. So I'll just say app, and we have to tell what package. So package main is the entry point for the program. So we'll do package main, and then we'll do function main, and then we will there's a Go linter that I highly recommend you install in VS Code. It is beautiful. It is great. It auto formats and auto includes things. So we're just going to do a quick hello world to make sure we did it right. And there it did. I saved it and included. It imported the FMT, which is what it uses to print errors and just anything to the stream. You can do go run, or you can do go build to build it, but we're not going to do that because we're going to do go run because don't want to build it and wait for it to compile this really thick binary every time I want to run my code. So we'll do go run, and then where we're running it, boom, hello world, awesome. So now to get to the port scanner part. So we're going to start off with, we're going to give an address. So it likes to do this : equals thing to dynamically initialize and assign at the same time. It's a what? I'm not calling it that. I'm not calling it that. So we're just going to do the localhost. And then we're going to do a list of ports. And that'll be, it's a slice in Golang. So it's a slice. It's what they call their their data structure. And we're going to just do 1, 2, 3, 4. We're going to copy it over. Or copy it over from my other one. Ignore this.
Are you copying blood?
I'm copying this list because I am not rewriting all. We are not writing all these again. There we go. So this just has a bunch of ports, and including ports 80, 443, 22, 20, 21 are like the main ones. And I just put a bunch of other ones to show that it's not just getting open ports. Okay, cool. So it's going to be erroring right now, and the errors are because it doesn't like when you don't use the variable. So cool. We have to like use the variable now, or it's going to be mad. So let's go and make a package. So we're going to make a package. And inside packages, we're going to make a folder name, and the folder name is what your package is going to be called. It gets really upset when you don't make it the same name. It also gets upset when you don't write it in all lowercase, I'm pretty sure as well. So we'll do scanner package, and we're going to do tcp.go. Cool, so now we have a new package, and it's part of the scanner package. And we're going to do start tcp scan. And it's going to take the address, which is going to be a string. It's going to take the list of ports, so ports. And that is ints. And does it need anything else? Do we need anything else? No, that should be fine. Cool. So now we also want a function for port scanning. To check if the port's open, we're going to try to establish connection to it. And if we can establish the connection to it, we are just going to close it off and say, cool, it was open. And we're going to say it was closed if it times out or rejects our connection. So that's kind of like a simple port scanner idea. That's like networking concepts. This isn't by any means a good port scanner, but it will work in tests if TCP ports are open for most of the time. So we also want another function that's going to scan the port. And that's going to take, we'll give it the, we'll also give it the address. And we'll give it a singular port. And that's going to tell us if it's open or not. So, cool. So now, we need to loop through all the, we're going to do, real quick, we're going to just have it print what we're doing. So we're doing a TCP, oh, my bad, we need print that. So we're doing a TCP scan on this IP address. Awesome. And we're going to do address. Awesome. Why is it complaining? Oh, we needed an import. Cool. So now we're going to loop through. Oh, well, we're not going to do concurrency right away. We're going to loop through. Is that big enough, by the way? Oh, yeah, that's okay. Oh, too big. Oh my god. All right, all right. Please hold. There we go. All right. So for loops are similar to C but without parentheses. So what you doing over there?
We're making fun of you.
That's fine. That's fine.
It had nothing to do with you, don't worry.
Length of ports and I++. Cool. And we're gonna run through. We're going to run through and test each one of these ports. So what we're going to do now is we're going to call the function scan port, and we're going to give it the address it needs for scanning, and we're going to give it the port number it needs, so port I. The networking is super simple in Go. Net.dial. Oh, I spelled dial wrong. So we want to do dial.timeout. Oh, we need to make the address. Forgot about that. So here's what we're going to use to connect is the connection address. So we need to take this address, which is here, and we need to concatenate the port to it. And you can just do that. And this is like the whole Pythonic thing that I was talking about. You just kind of slam things together like this. And C, this would be painful. But here's the C part. You can do Is it I to A? No, it's string. Oh, there it is. I to A. So there's the I to A to convert your int to a string. So cool. Now we have our string address, so we can connect. I want the autocomplete. I forgot the. Oh, there we go. Okay. So network string is what type of connection it is. We're making a TCP like library package. So we're just gonna put TCP. The string, which is the address. So cool, we have that. And then the timeout time. So let's say 10 seconds, because that seems kind of reasonable for testing. So you need the time, and then you can multiply it by time time.seconds. So you can do minutes, hours, etc. And that'll give you the actual time instead of milliseconds. Cool. So we have that. And here's the really fun thing. Oh, hold up. We need to get the actual connection. So this is like a socket type deal. I don't know if you would call it quite a socket in Golang, but it's the connection. So we're going to do con for the connection. And a lot of things in Go return the connection, or like they return what they want, or like multiple things of what they want, and then an error. So if you take a look at the autocomplete here, if it'll pop up. What? Control P? Oh, there it goes. Okay. So you see at the end of the function there, it says right there, it returns a net.con, which is the actual active connection object that it has in its like networking library, and it returns an error. And then what you do a lot of the times in Go, and you'll do this a lot, I think this is the most frustrating thing in Go, they don't have something to handle this, but you'll do if error is not equal to nil. Is what? Yes, or you could do what a manual said, and you could just put an underscore and ignore the error, but that's not good programming, so we're not going to do that. Also, it's this functionality is essential to the port scanner because we need to know if it failed. Because if it failed to establish the connection immediately, it failed. So now, if it failed, we want to tell the program that we did not establish the connection. So what we'll do tab to tab it over a little bit, make it look a little pretty. We can do the port number, so that's what? $, or that's %D for the integer. And then we will say closed, because it is now closed, and we will give it the port. Cool. So if it fails, that's what's going to happen. And then we have this open, though. Oh, let's just do open real quick. So if it succeeded, it's open, right? So if it succeeded, it's open. But we have a problem now. We still have the connection open. You can just do con.close connect, or like con.close like this at the end, and that will work. But Go has this really cool feature called defer. So defer will run that whatever you tell defer to run, but at the end of the function, no matter what. So even if the program crashes or errors out, it will still run con.close, and then it will close the connection for us. And this is really useful for reading files. It's really useful for the socket and the networking stuff. Pretty much anything that you have open, you're gonna want to just run defer the close reciprocal of it, because it's gonna just like end it for you, and that's gonna be it's good for error handling, and it makes sure there's not a lot of memory leaks as well. Yeah, leaks. Cool. So now we have all this set up, and it's going to run through and print all these and then be done. So we're going to go back here, and now to call like all the stuff we just did, or you need to do the package name. So scanner dot, and we can do what we do TCP. Yeah, start TCP scan, and we need to give it the variables, so address and ports. Cool. And it's going to complain because I didn't import the package. Oh, scanner is already a package. Yikes. And we're going to name it real scanner real quick. Alrighty. That's a good point, Emmanuel. So in Golang, it exports the functions when you capitalize them. So if it's a local function, you don't normally want to capitalize it.
Is it gonna print closed and open if it's closed?
What? No, so, oh, actually, good call. Damn. Live coding. Forgot to put the return. If it fails, it will return and stop. That was called by Loudon. And yes, Bradley, Golang is very opinionated about how it wants its things formatted. That's why some people actually end up liking it, because it is like that. All right, cool. So now imported. So that's that Go and Knit thing. It's up. It was up there. Real Scanner is what I called the like the actual project in the Go mod right here. If you don't remember, so there it is. And then it is the package. So that's the directory. You could do another directory, but package is like what you should do. And then Real Scanner is the package. You can get even deeper into it. Like for, say, you have a C2, you have like listener, and then the type of listener. Yeah. Was that a lot of flashback for you?
Yeah. Also, getting out.
Where, bro? Oh my god. True. Hey, none of that. All right, cool. So we run it. Oh, wait, I didn't put new lines. All right, let me put the new lines. But it worked. It's just really ugly. How long are we at? I don't want to go too long. I don't want to ramble. Longer than I thought.
Quick, bro.
Let's go. All right, there we go. So there they all are. That's a little messy though. See, they're all like listed. So we're gonna just take that out, and then we'll run it again. It's cool. I have SSH running, and I have a web server. So status is Apache 2, right? Yep, my Apache web server is running, and same with my SSH server that I turned on. There it is, it's running. So cool, it got it, and there wasn't that stuff running on the other ones. So that's really cool, and that was still really fast. But what if I wanted to like increase timeouts, and I wanted to hit a bunch of them at once, and my list wasn't just like 10 to 20 ports, and it was like a bunch of ports? We're gonna want to thread that, right? So we're gonna use the concurrency, and this is where it gets spicy. So here's what we do for concurrency. We simply just say go, and it goes and does its thing. That's it. So this is how you spin up a thread and go. It's super simple.
Wait, what?
Okay, it's not a thread. It's not. It's. I should correct myself. It's not a thread. It's the concurrency. What's it do, Fred?
It's a go routine. So these are the single threads spreading that out.
Yeah, it's called the Go routine. Go look up what it is under the hood. It's black magic. It's great. But that's all you need. The issue now, though, is if I run this, it's going to freak out, right? Oh. These can get messy. So you could see it didn't actually print anything. And that's because I didn't set a wait group. And a wait group is like the, how would I compare it in C? It's like the, what's that thing called? Like wait for in C or whatever it is. For what? Yeah, wait for a single object and see. Like you can't. We didn't do that. So we need to do something called a wait group to actually wait for the concurrency to finish at the end. So we're gonna make a wait group. So it's called sync.waitGroup, and there's you can see all the mutex stuff in there too. Spicy. There it all is. So the wait group is going to wait for it's going to wait for each of the actual like objects to be, once it hits the wait group, it's going to wait for every go routine to finish that was added. Or it's going to wait for X amount of like wait groups to finish. So what we can do is we can add to the wait group one, every time we start a go routine, we're going to add to the wait group. Because what's going to happen is once we tell the go routine to go, we're also now going to pass it the wait group. We come down here and we do the first thing we're going to do in here before we do anything else is we're going to use that defer. Ooh, all right. And we're going to go weight group dot done. So this tells that weight group that cool, take one away from your adding, where adding adds one. So now we have a weight group where every time a thread or a go routine starts, then once it's done, it takes it away. So now we're going to wait for it to be 0. So to do that, we now do weight group dot wait. Cool. So now what it's going to do is it's going to loop through all those, and it's going to start them in grow routine. So it's going to get them all at once. And then it's going to sit at this wait until until the weight group counter is at 0. It's going to wait till it's done. Nice. So we have a negative weight group counter. And this is what the problem is. I didn't know what it was. But if you run it again, I bet you it will work. So this is the fun about concurrency in Go. I don't know what the hell's going on here. I don't know how to fix it. Yes, Bill?
Maybe make the WG done after you actually do the port scan.
It is done after that. That's what defer does.
Oh.
So defer will make it done whenever the function exits. So whenever it hits like a return value, so either at the end or when I have that return, it'll say done.
Yeah, that's taking a long time.
Yeah, I don't know, man. So something tells me I didn't do weight groups right in this. So definitely look at this. The timeout's 10 seconds. So this is the problem. So I feel like when I run it, it either adds too many weight groups because now it's sitting here hanging at weight group. And then also on top of that, it is adding 1. So I feel like when it gets negative, it gets too many dones and it goes negative. So it's freaking out like here. See, yeah, negative weight group counter. That's a problem. But then here, obviously, it's not 0 yet. So it has over 1. Because if it was 0, the program would just be done. So if you want, we could try to do some live debugging.
Yes.
No, just the print statements.
Was it what?
Yeah. No, when
Look at your problem.
Call copy block value contains. This is probably the problem right here.
well, I mean, if you
I will do a debugging, one debug thing, and then I'm done. Y'all can figure it out at home. It's not a hard program to write. Took me 10 minutes the second time. So we got our weight group. Oh, no copy. Look at that. So let's see what happens to it. Oh, look at that. Okay, cool. So it adds... Oh. Shit, there it goes. All right, I'm not going to bother debugging this on stream because it's going to be a mess and a lot of Googling, and I don't know the answer. So that's how you make a simple port scanner. Add the concurrency yourself. Make it work. That's all I got.